So as in the previous video, we can say that for a quadratic polynomial, there are three cases possible. So for a quadratic polynomial, either there can be two solutions or there can be one solution, and there can also be no solution. So there are three cases. First one, two solutions. Second one equal solution. And third case, no solution. So these are the three cases possible for a quadratic polynomial. So here you can see by the parabola itself, it's a quadratic polynomial. Parabola shape will come for a quadratic polynomial only. Now, in a cubic polynomial, we have seen that three solutions are possible. Okay, three solutions are possible, and it can be either three or two solutions or one solutions, as it is given in these examples. Now, this is our first question, example 1. So, some pictures of graphs are given. We have to, for each graph, find the number of zeros of p of x. Now, for this first one, how many zeros are possible? You just only have to look at the x-axis. So, the graph touches the x-axis at one point only. So, one solution is possible. Here, the graph touches the x-axis at 2 points. So, two zeros of the polynomial are possible. Now, here the graph touches the x-axis at 1, 2 and 3. So, three solutions are possible, or zeros of the polynomial are possible. Now, here it's a linear polynomial, as you can see from the graph. It's a linear polynomial and it's a straight line. So, the graph touches the x-axis at one point. So, only one solution is possible. Here the graph touches the x-axis exactly at one point. Even though it's a quadratic polynomial, there is only one solution or one zeros in this particular polynomial. Now for sixth one, it touches the x-axis at 1, 2, 3 and 4. So 4 solutions are possible. Okay, 4 solutions are possible for this particular graph. So we have 4 zeros of the polynomial in this case. So I hope this is clear. Now, exercise 2.1, our first question. The graphs of y equal to p of x are given in figure 2.10 below. For some polynomials p of x, find the number of zeros of p of x in each case. Now, the first one, we have a straight line, but it's parallel to the x-axis. It is not touching the x-axis, so no zeros are possible. Okay, so no zeros are possible. Now the second one, the graph touches the x-axis exactly at one point. So only one zero is possible. Now here the third one, the graph touches the x-axis at 1, 2 and 3. So 3 zeros are possible. 3 zeros are possible in the third one. Now the fourth one, the graph touches the x-axis at 2 points. So 2 zeros are possible, and also it's a quadratic equation because it's a parabola. So this particular shape, U shape, we call it parabola. Okay. Now the fifth question, 1, 2, 3 and 4. So 4 zeros are possible since the graph touches the x-axis at 4 points. Now the sixth one, the graph touches the x-axis at 1, 2 and 3. So the graph touches the x-axis at only 3 points. So 3 zeros are possible. 3 zeros are possible for the sixth graph. I hope this is clear. Now next we have the relationship between the zeros and the coefficients of a polynomial. So for a quadratic polynomial, we know the general form of a quadratic polynomial. It's ax square plus bx plus c is equal to 0. Now, here the coefficients of the polynomial are a, b and c. So we are forming a relationship between the coefficients or the constant and the zeros of the polynomial. Okay, so suppose the sum of the zeros, first relationship is that sum of the zeros. So we are taking the two zeros, that is alpha, two zeros as alpha and beta. The sum of the zeros will be the minus of b by a. B is the coefficient of x and a is the coefficient of x square. So alpha plus beta is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. That's our first relationship. Now, second, the product of the zeros. Suppose if alpha and beta are the zeros of the polynomial, their product will be equal to c by a. C is the constant of the polynomial and a is the coefficient of x square. I hope this is clear. So the product of the zeros and the sum of the zeros. Sum of the zeros is minus b by a and the product of the zeros is c by a. It's a constant term divided by coefficient of x square. Now this is the case for a quadratic polynomial. Now we have for cubic polynomial. So if we have a cubic polynomial, then we have we can have at most three zeros. So alpha, beta and gamma. These are the three zeros. So and the general form of a cubic polynomial is ax cube plus bx square plus cx plus d is equal to 0. This is our general form. Now from this, a is the coefficient of x cube, b is the coefficient of x square and c is the coefficient of x and d is our constant term. Now here the sum of the zeros, that is alpha plus beta plus gamma, we have minus b by a. Okay, just like the before, we have minus b by a. So minus of the coefficient of x square divided by the coefficient of x cube. Now the next relationship is alpha into beta plus beta into gamma plus gamma into alpha. Now this we have c by a, where c is the coefficient of x and a is the coefficient of x cube. Now here next is the product of the zeros. So alpha into beta into gamma, we have minus d by a, where d is the constant and a is the coefficient of x cube. So these are the three relationships possible for a cubic polynomial. Sum of the zeros we have minus b by a, then alpha beta plus beta gamma plus gamma alpha we have c by a, and alpha into beta into gamma we have minus d by a. Okay, so these are the two relationships between the zeros and the coefficients of the polynomial. One we have for the quadratic polynomial and the another one we have for cubic polynomial. Then what about a linear polynomial? We know that the linear polynomial we represent it as ax plus b is equal to 0. Then obviously x is equal to minus b by a. Okay, that's the only thing we have. And now moving further, this is our example 2. We have to find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Now, our polynomial is x square plus 7x plus 10. Now, we have to find the zeros first and then we have to verify the relationship between the zeros and the coefficients. So, First of all, we can equate this with 0 to find out the factors, or even if you don't equate also fine. Okay, so this we can write it as we need a product of 10 and a sum of 7. So what can be the factors of by which we can split the middle term? So 5 and 2 can be the factors. So we can write this as x square plus 5x plus 2x plus 10 is equal. Then here we can take x outside, then x plus 5 plus 2 into x plus 5. So this will become x plus 2 into x plus 5. Okay, so these are the factors of this given polynomial. So here if we are equating this to 0, then either x plus 2 is equal to 0 or x plus 5 is equal to 0. Now, when we equate this to 0, either x plus 2 is equal to 0 or x plus 5 equal to 0. So, either x equal to minus 2 or x equal to minus 5. These are the two zeros possible for this particular quadratic equation or quadratic polynomial. Now, we have to now verify the relationship between the zeros and the coefficients. So, from this we can write alpha is equal to minus 2 and beta is equal to minus 5. So, first of all, the sum of the zeros is equal to alpha plus beta, which is, we know it's minus b by a. So, here what is minus b? It's a minus 7 and a is 1. So, minus 7 by 1 we will get. Now, here we got minus 2 plus minus 5. So, that also we are getting minus 7. So, that's verified. Now, product of the zeros. Which is equal to alpha into beta, which is constant term divided by the coefficient of x square. So, c by a. So, here we have c as 10 and a as 1. So, 10 by 1 we are getting. So, alpha into beta, which is minus 2 into minus 5, which is also we are getting 10. So, 10 is equal to 10. So, that's also verified. So, this is equal to the constant by the coefficient of x square. Here it is minus of coefficient of x by coefficient of x square. So that's verified. I hope this is clear. So first we did the factorization, we got the solutions and we named it alpha and beta. Then we found out the sum of the zeros and the product of the zeros.